In this tutorial, we will be discussing how to simplify the different functionalities that we have created so far using Telegram commands. To begin with, open the Telegram JOJ's file in your code editor and add a new command that retrieves the login URL. This command will remove any unnecessary spaces and send it as a message to the Telegram bot. However, before you test it out, ensure that you start ngrok and update the URL in the Telegram bot. If you need any assistance in setting up ngrok, please refer to the link provided in the description. I have already added an ngrok command to my package, JSON file, that specifies the path of ngrok. Once you have obtained the new URL, update your webhook using Postman. After updating your webhook, navigate to the Telegram bot and use the new login command. If successful, the login URL will be displayed. Click on the URL and select the Google account where your photos are stored. It's redirected to the gToken endpoint with a code in the query parameters. Let's get this code and get a refresh token. In the index file, remove all the testing methods and create a new condition where request path equals gToken. We will then take the query parameters from the URL and call the getNewRefreshToken method created in the previous tutorial. After retrieving the refresh token from the response, we will update the token in our database and return a success message. Let's test it out. Check our database to confirm that the refresh token was updated successfully. Now, let's create a new command that pulls all the Google Photo URLs and updates them in our database. Create a case called updateMedia, which retrieves the refresh token from the database and requests a new access token from Google. With that access token, we will retrieve all the photos from the Google account and save them in an array called allMediaItems. Using our batchWrite method, we will save all the URLs in our database and send a success message to our Telegram bot. Let's test it out, ensuring that the media items database is empty before executing the command. Finally, let's add our last command to pull a random photo from these URLs. First, let's create a method that can send photos to our Telegram group. Let's call this method sendPhoto, which takes 3 arguments. 1. Message object. 2. Photo URL, the URL of the photo we want to send. 3. Caption, if we want to add any caption to the photo. We'll make a post API call to the sendPhoto method and pass these arguments. Let's handle our surprise case. We'll get a random photo URL from the database using the getRandomPhoto method from the previous tutorial and send it using the sendPhoto method we just created. Let's test it out. Amazing, we are finally able to pull a random photo from our Google Photos. Let's recap. Through our Telegram bot channel, we input the command getLogin, which acquires a new login URL for the Google OAuth consent screen. This URL is then sent back to our Telegram channel. When we click on the URL, it prompts us to select a Google account from which we want to pull Google Photos. Once we select the account, it will redirect to a path gToken with a code in query parameters. We extract this code from the URL and use it to obtain a refresh token, which we save in our database using the updateRefreshTokenInDB method. Now, when we input the updateMediaItem command, we retrieve the refresh token from the database. With this token, we obtain an access token, which we use to retrieve all the URLs associated with the Google Photos account. We then save these URLs in our database using the batchWriteItems function. Once the URLs have been updated, we send a success message back to the user. Finally, when we input the surprise command, we call the getRandomPhoto function, which retrieves a random photo URL from the database and sends it to our Telegram account. Whenever we have new photos in our Google account, we can call the updateMedia command again. However, there is an issue when we execute this method multiple times. It appends the new URLs to the existing ones. To fix this, we can create a method called clearMediaItemsData, which clears all the data from the media items table. In our Telegram JJ's file, inside the update media case, we first clear the database and then retrieve the new set of URLs to update. To test this out, we currently have 17 URLs in our database with IDs starting from 73. After executing the command, the IDs have changed to 92, and we have 17 new rows. By executing this command whenever new photos are added to our Google Photos, we can ensure that our database is always up to date. Now, we will focus on improving our error handling and moving our password to environment files. We will explore how to restructure our code for better maintenance. Our first task is to improve the logging system to enable better error message logging. We will create a file named helper.js and add a method called error handler, which will handle errors occurring in our code. This method takes 3 arguments: the error object, a unique identifier called name, and the location where the error is logged called from. The logger function logs the error messages. For the locale, we can use console.log, but in production, we can use any logger function of our choice. We will add start and end log lines, starting with the name of the error message. We will also handle errors from the Axios library, which can occur in multiple ways. If there is an error response, we will log the error response details. If an error occurs during the request call, we will log the error message. We will also log the JSON format of the error provided by Axios. Next, we will handle database errors, specifically from Postgre. If the error is from Postgre, we will log the error. Now, we will hook this error function. Whenever there is an error, we will call the error handler with the error object and function name for ease of tracking and PG, as errors are coming from the DB handler. We will change this method in every method. Next, we will fix our Axios errors. Instead of calling Axios, we will return a new promise and handle the error. Whenever the API fails, we will call our error handler with the exception and method name, and Axios as the third argument. We will update every method. Most of the functions used inside handle messages have proper catch blocks, but just to be extra cautious, we will add a try-catch block to prevent server breaking. The same thing applies to the index file. This is just an outline to debug the logs when something fails, but there are better ways of doing error logging. I will provide some links in the description for that. We will also improve our methods to give the proper data. For example, refresh token gives the response object. Instead, it should give the refresh token. We will update all our methods to send proper data and also log if the data is not available. We will clean up the file and remove unnecessary code. Now let's handle passwords and usernames. Ideally, it's not correct to keep sensitive information in the code. Instead, we can create an environment file from which we will read this information. We will use a package called dotenv. It allows us to have a file called dotenv where we can keep our secrets, and we won't commit this file to our repository. When we deploy this application in production, every cloud service will provide a UI to add these environment variables. We will require this dotenv on the root level. We can access the values inside the dotenv file using process.env.variablename. We will install this package and create a new file called dotenv. We will ignore this .env file and add our bot token and Postgre database details. We will import the .env package on the root level. This is how we should import it. We will test it out by logging in and accessing the values using process.env and the variable name given in our environment file. Every system and server will have their environment variables, and this package combines them together. We will then update the values. Finally, one important thing to note is that currently, anyone can access this bot by searching for its name and start sending commands. This means anyone can call update media or surprise and get the photos. Right now, there is no option to make bots private, but we can keep some security in our code. Let's send the surprise command. We don't see any photos. Let's see how our error logging is working. We can see all the errors that occurred in send photo, but I see all the URLs are proper. Let's access this photo URL in the browser. It's giving a 403 error. Oops, yes, the URLs we are saving are short-lived and they expire after some time. Let's fix this. In our current implementation of the update media method, we retrieve all the base URLs and save them. However, it is necessary to update the logic slightly to improve efficiency. Before doing so, we should refer to the Google Photos API documentation, specifically the list API. In the response, we are saving the base URL which expires after a short duration. To avoid this issue, we should save a unique ID instead of the base URL. This ID can be used to retrieve a URL that can be accessed at any time using the get method. This will allow us to obtain the base URL. To implement this, we need to update our code. Instead of base URLs, we have to save all the IDs in our database. When the surprise command is executed, we will randomly retrieve one of these IDs from our database and call the get API to obtain the new base URL. Before proceeding, we need to modify our database schema by deleting everything and changing the column name from URL to media_ID. We will obtain image IDs in our code, and the query will need to be updated accordingly. In the case of the surprise command, we're obtaining a random photo ID. We will need to call the getMediaItem method and pass this ID to retrieve the photo URL. Let's test this out. After calling update media, we received a success message. Let's check what was updated. Amazingly, we can see all the IDs. Now we need to select one media ID and get its image URL. Let's try the surprise command. Unfortunately, it seems like there's an error. Thankfully, our logging is helping us to identify the issue. It appears that we are still using an old method in handle message. We need to update it and test it out again. We've missed something again. It seems like we are still using URL somewhere. Inside getRandomPhotoID, we need to use media_ID in the query instead. Also, in getMediaItem, we need to pass the access token information. I hope everything will be fine now. Whenever I kill my local host, I have to restart my ngrok, but I don't know why. If you have any other solution, please let me know in the comments. Let's return to our original concern, how to restrict access to others. Whenever a message is sent in our group, a message object is received that contains a unique chat ID for that room. This chat ID is between me and the bot. We'll save this chat ID in the Telegram joy.js file. If we add this chat to any group in the future, it will have its own chat ID. Let's create a group and save its chat ID. In the handle message function, we'll first check if the message is coming from one of the chat IDs we know. If not, we'll send a simple message. This adds security to the bot. We can also add rules for each command, such as who can update media and who can access the login URL. We've achieved what we set out to do. In the next tutorial, I'll show you how to deploy this application using free resources and share more ideas and tips, so you can have even more fun with this project. Thank you for tuning in. I will see you in the next tutorial.